Your cat has been following you around for 3 days, not normal following. Not the kind where they want food or a warm lap. They keep pressing their face against your stomach, sitting on your chest, watching you with that fixed, unblinking attention that usually means something is wrong. You go to the doctor mostly to stop worrying. The doctor finds something early enough to treat. You think about the cat. You wonder if they knew. This happens more than most people are ready to believe, and science has spent the last 20 years trying to figure out exactly how. Let's start with what animals are actually detecting when a body gets sick. Every illness, from a bacterial infection to cancer to the early stages of a seizure, changes the chemistry of the human body. Inflammation triggers the release of specific compounds. Tumors produce volatile organic chemicals that the body expels through breath and sweat. Blood sugar crashes alter the balance of gases coming off your skin. The body announces what's happening to it constantly, in a language made of molecules, and most of us have lost the ability to read it. Some animals haven't. Dogs are the most studied case, and the numbers are hard to dismiss. A 2011 study published in the journal Gut tested whether dogs could detect colorectal cancer from breath and stool samples. The dogs correctly identified cancer samples with an accuracy rate of around 95% across both breath and stool. That's not an outlier. Multiple studies across multiple cancer types have replicated similar results. Dogs have identified lung cancer, ovarian cancer, bladder cancer, and prostate cancer through smell alone, often with accuracy that rivals or exceeds standard diagnostic tests. The mechanism is real and measurable. Dogs have roughly 300 million olfactory receptors. Humans have around 6 million. The part of a dog's brain dedicated to analyzing smell is proportionally 40 times larger than ours. When a dog sniffs a person with cancer, it isn't performing a miracle. It's doing what it was built to do at a sensitivity level we can barely comprehend. One researcher described it this way: if you could smell what a dog can smell, you could detect a single drop of a substance dissolved into an Olympic-sized swimming pool. That's the instrument they're working with. But it isn't only cancer. Seizure alert dogs are trained to respond before an epileptic episode begins, sometimes up to 45 minutes in advance. What they're detecting isn't fully understood, but the leading hypothesis is that subtle chemical changes in sweat or breath precede the neurological event. The dog picks up the signal before the person's own brain registers what's coming. Some of the documented cases don't involve trained dogs at all. Pet owners have reported their untrained family dogs becoming agitated and clingy shortly before a seizure, with no training, no conditioning, just the animal reading a signal the person couldn't see themselves. Diabetic alert dogs work through a similar channel. When blood sugar drops dangerously, the body produces a compound called isoprene, and the ratio of certain gases in the breath shifts measurably. Dogs trained to detect hypoglycemia have been shown to alert their owners before blood glucose meters even register a dangerous reading. They're not interpreting a number on a screen. They're reading the body directly. Cats are harder to study because cats cooperate with research on their own schedule, but the documented cases are striking. There is a cat named Oscar who lived in a nursing home in Providence, Rhode Island, and who became well known for curling up beside patients who were within a few hours of dying. Staff began using his behavior as a clinical signal. In cases where Oscar settled in beside a patient, the nursing staff would contact families to come quickly. He was accurate enough times that physicians began writing about him in medical journals. The working theory is that he was detecting the specific compounds released as cells break down in the final stages of organ failure. He wasn't sentient of death. He was following a scent. Rats have entered this conversation in a way that surprises most people. An organization called APOPO has trained African giant pouched rats to detect tuberculosis in sputum samples, working in regions where laboratory access is limited. A single rat can screen more samples in 10 minutes than a lab technician can evaluate in a day. The rats have detected positive TB cases that standard microscopy missed entirely. They're also being trained to detect landmines through smell. The same biological sensitivity that makes animals useful for detecting disease makes them sensitive to the chemical signatures of illness in ways we are still mapping. There's a dimension to this that goes beyond smell. Animals also track behavioral changes that accompany illness, and they track them in real time. When a person is sick, the body diverts resources, movement patterns change, posture shifts, the face changes subtly, and animals process those shifts through systems that are faster and less cluttered than conscious human perception. A horse owner who has spent years with the same animal will tell you the horse knows something is wrong before anyone says a word. The horse is reading cortisol levels, micro changes in movement, the way the person carries themselves differently when pain is present. The body does not keep secrets well from an animal that has been paying close attention to it. What makes all of this more than a series of interesting anecdotes is that researchers are now trying to reverse engineer what the animals already know. Scientists are building electronic noses, devices that attempt to replicate the olfactory sensitivity of dogs, specifically because dogs keep detecting things that our machines can't. The dog is ahead of the technology. It has been for a long time. In some research contexts, they're using dogs to validate whether a new electronic detection system is working correctly by checking its results against what the dog found. The animal is the control. There are limits, and they matter. An animal can detect that something has changed in the body. It cannot tell you what changed, or why, or whether it's serious. A dog that alerts to illness is not giving a diagnosis. It's registering a deviation from what it knows is normal. That's powerful, but it requires human interpretation, trained protocols, and medical follow-up to mean anything actionable. Animals also respond to anxiety and distress in ways that can be confused with illness detection. Stress produces its own chemical signature, and a dog responding to a frightened owner isn't necessarily detecting disease. The signal overlaps. But what runs through all of this, from the cancer-sniffing dogs to Oscar the nursing home cat, to the seizure alerts that arrive before the seizure, is the same basic fact. The body is communicating constantly in a language made of chemistry and movement and microscopic change, and we have surrounded ourselves with creatures who are fluent in it. We built our lives alongside animals in part because they were good at reading the world in ways we couldn't. That hasn't changed. The chemistry of illness hasn't changed. What's changed is that we now have enough data to take it seriously. The animal was never doing anything mystical. It was just paying attention to something real that we had stopped noticing. And in some cases, that attention is the difference between catching something early and not catching it at all.